Hello, welcome back. Today we're gonna see about the buckling of column. Okay, so first, what is column? Column is nothing but a member of a structure which is mainly used to withstand axial load. That is, if this is a column, okay, so this is a vertical member and it is only to withstand the axial loads which is acting on the structure. ஓகேங்களா? So first one column. Column என்ன? ஒரு vertical member. இந்த மெம்பரில் மேலிருந்து அதாவது இந்த டைரக்ஷனில் vertical directionல ஆக்ட் ஆகிற forces எல்லாமே இதுதான் தாங்கும். So column means both ends are fixed. If one or both ends are hinged or pin joint means it is called strut. Okay, so this one is called strut and it is not at all a vertical one. Okay, so column and the strut. Okay, so these two things is mainly to withstand the axial loads. And here there are two types. There are two types of columns, short column and long column, as we know. Short column means it will fail only by crushing. Okay, so if it is a short pen means if you apply forces on like this means it will get crushed. Whereas long column means it will fail by buckling. It will start to bend. So this bending is called buckling. The column not failed by crushing but by bending. So it is not at all crushing but it occurs bending means that is called the buckling. So this is main buckling of column. Then what is buckling load? Buckling load is also called crippling load. Okay, so this is a load at which the column buckles. So this is called the buckling load. So due to this load the column start to buckle. Buckling load na இந்த வளைவுக்கு காரணமான load. That is what buckling load. இந்த வளையின் இந்த மாதிரி வந்து long column வந்து வளையும். அது crush ஆகாது, உடையாது, but it will bend. This is called buckling. Okay. Next one. Crushing stress, which is equal to crushing load by area. Normally stress which is equal to load by area. If it is crushing stress means crushing load. That's it. Okay. And direct stress, bending stress. So there are two types, direct and bending stress. In a column, direct stress means P by area. Generally just take the load alone, P by area. Next one, bending stress means it will have some distance, right? So load into distance by, it's not area, section modulus. So this is what bending stress. Okay, this E is nothing but the maximum bending, that is maximum the bending distance. Okay, minimum stress and maximum stress. So we can find from these two, direct and bending stress. What is minimum stress? Minimum stress will be equal to just direct minus the bending. If you add both, it will become maximum stress. Okay. Next one, the column will fail. So the column will fail. Maximum stress is greater than the crushing stress. Okay. So we know the maximum stress is nothing but direct plus bending, right? So if you add them both, it will be greater than the crushing stress means the column will tend to fail. So we can easily identify the column as failure there. Okay. So maximum stress வந்து அதிகமாக இருக்கணும் crushing stress விட. அப்படி இருந்தால் அந்த column கண்டிப்பாக fail ஆகிருக்கு. Very long column means has only buckling stress. So it is failed only by the buckling because the crushing stress will be constant there. So the direct stress will be small and it is neglected. So only buckling stress. So it is failed only by the buckling. So buckling of column, under this thing they have given Euler's column theory. Okay, so Euler's column theory. There are some assumptions. Okay, what are these? Column should be perfectly straight and the load which is applied is only axial. Okay, so we know that column means it should be straight and the load applied should be axial. And the cross section of this column should be uniform. If you take any section here, the cross section of the column should be uniform. Okay, because it is straight and it has the same dimension means it will have the same uniform cross section. Next one, column's material is elastic, homogeneous, isotropic and it should obey the Hooke's law. So it should be elastic, that's why it will tend to bend. Okay, and it should be homogeneous and isotropic, that is it is made up of only same material. Then Hooke's law. Hooke's law is nothing but stress is directly proportional to strain, right, within the elastic limit. Okay, so this is what the material should be. Okay, next one, the length should be very large as compared to the lateral dimension. Like lateral dimension means depth, breadth. So L should be greater than these depth and breadth. Next one, direct stress. So direct stress is always less than bending stress. Yes, because in long columns it is almost negligible. Column fail only by buckling. Yes, it is a long column, so it will fail only by buckling. Self-weight is neglected. Okay, self-weight is here neglected. So these are the 7 assumptions comes under the Euler's column theory. So buckling of column under following end conditions. So the buckles will occur under the 4 end conditions. So let's see that. First one is both the ends of the column are hinged. Okay, this is what hinged. Okay, so both the ends of the columns are hinged. You can see here it is hinged and it start to buckle. Here you have to remember that the sign. Okay, this is very, very important actually. If the column, this is what the column. If the column bends like this, okay, if it is hinged means it will bend like this, buckle. So this is what concave lens. So concave means it is negative. Whereas if it is fixed here and it is free here means it will bend like this. Right? So this is what convex, like this. Okay, this is concave and this one is convex. So this is this bending. So this is positive symbol, positive sign for that. Okay, so generally if you want to write a bending moment means it will be like minus p e, the distance, p into distance. Okay, so it will get a negative symbol due to this concave. Okay, so first one is both the ends of the columns are hinged. Okay, so the crippling load will be pi square EI by L square. Pi square EI by L square if both ends are hinged. Whereas one end is fixed and other is free means it is convex, right? So positive symbol will be there. So P, which is equal to pi square EI by 4 L square. The 4 is added in the denominator. If both ends are fixed means crippling load P will be equal to 4 pi square EI by L square. So 4 will be added in the numerator. Okay, just same formula. One end is fixed and other end is hinged. Means the P value will be equal to 2 pi square EI by EL square. So here it is 2. So we can easily say 2 is in the denominator, 4 is in the 2 is in the numerator, 4 is in the numerator and 4 is in the denominator, and then the general formula here. Okay, so both ends are hinged, one end is fixed and one end is free, and both ends are fixed, and then last one end is fixed and other end is hinged. So 4 end conditions. Next one, this is an important one. What is effective length or equivalent length of the column? Which is nothing but LE. So this is the effective length is mentioned as LE. Just we need to replace this LE for L. So usually the formula will be pi square EI by L square. So instead of L, we need to replace it LE square. Okay. So here you can see here pi square EI by LE square. This is a common formula. So from this formula, we can easily identify for the 4 condition. You can see here these are the 4 conditions. 4 is in the denominator, numerator, and 2 is in the numerator, right? So these are the formulas for the 4 conditions. And this is the same. Effective length LE is same. Just replace this LE by L. Sorry, just replace this L by LE. So this is the thing. After that, you can see here, just compare these 2 formulas. Compare it. If you compare this, LE will become L. So LE is equal to L here. Here, LE which is equal to 2L, because this is LE square and 4L square. If you take square root, means it will come as 2L. So LE which is equal to 2L. Here L by 2, because here 4 is in the numerator. Here 2 is in the numerator. So LE will be equal to L by root 2. So you need to remember these things. 2L, L by 2, L by root 2. That's it. For the formula LE. So just you can easily remember this formula alone and just substitute these thing in the formula. You can easily get this original formula. Okay, so this LE is nothing but the effective length or equivalent length. Crippling stress, which is equal to P by area. Okay, force by area. Okay. What is load by area? Stress which is equal to load by area. So crippling stress means crippling load by area. So this is crippling load or buckling load. Yes. So this one is what? Pi square EI by LE square. So this is the common formula, right? So in this thing, I'm just taking this I as AK square. K is nothing but stiffness. Okay. So K is nothing but, radius of gyration. Okay. K is nothing but radius of gyration. So I which is equal to A into K square. Just substitute this thing here and just take this K to the denominator. Okay. So you will get like this. So this is what the P. If you put in the stress means P by area. So already P has some area, right? So just cancel it and pi square E by this whole thing. Okay. Where K is radius of gyration. Okay. So this is what the crippling stress. Next one. What is slenderness ratio? Slenderness ratio. Ratio of actual length to the least radius of gyration. So like ratio of actual length by least radius of gyration. Okay, so L by K is, which is nothing but the slenderness ratio. Okay, next comes the Rankine's formula. Rankine's formula means it is based on the experiment of results. So this formula is mainly based on the results of the experiment. Okay. So experiment la irundhu kedaikira result vechi da indha Rankine formula vandu irukku. Okay. So idhula what is the formula means 1 by P which is equal to 1 by PC plus 1 by PE. What is P here? Crippling load by Rankine. Okay. What is PC? Crushing load. What is PE? Crippling load by Euler's formula. So there are 3 things. Just we need to add these 2 things to get the crippling load by Rankine's. So this is the formula. Okay. Crippling load PE by Euler's formula. Okay. So we know the formula here. முன்னாடியே நம்ம இதை பார்த்துருக்கோம். ஸோ pi square EI by LE square. Here LE which is nothing but effective length, which is also known as equivalent length. What is PC? PC means crushing load, right? So crushing stress into area. Okay, so we know these two thing formula. Okay, normally the crushing stress is constant because every column will have the same crushing stress, so it is constant. So the P always depends on the PE, right? That is crippling load due to the Eulers formula. Okay, so this P is always depends on the PE, whereas PE is depends on LE, because here this LE is the main thing, right? So LE, it is, these are all constant, so this one is the variable. So LE, which is nothing but the effective length. Okay, next one, if the column is short, here the column is short, so LE will be small. Yes, if it is small means we know PE, which is nothing but pi square EI by LE square, right? So this is the formula. Here this LE is small means this one will be large, so it is large, so 1 by PE will be small and it is neglected. So this one is neglected in the formula means 1 by P will always proportional to P. See, so we can easily take approximate value. So it is approximately equal actually. As you know, column fails only by the crushing when it is short, right? So here it is satisfied. If it is a short column means it is only depends on the crushing. Okay, crushing load. If the column is long, so LA is long and P is small and 1 by PE is large. So in this formula this is already neglected, and 1 by P, like it is a constant value here, and 1 by P is mainly equal to 1 by PE. So this is approximately equal. So we can easily say this ranking, that is long column is satisfied here. So it is not at all crushing. It is not, the failure is not all due to the crushing. It is due to the buckling. So this one is also satisfied. Hence the Rankine's formula is satisfied in long and short columns. Okay. So just substitute the two formulas. We know that PE is what? Pi square EI by LE square. Likewise PC is what? Sigma C into A, right? So just substitute these two values here and you will get like sigma CA by 1 plus A into LE by K the whole square. Here A is nothing but Rankine's constant, right? And what is value for A is A, which is nothing but sigma C by pi square E. So this is the value for A. And the next one is combined direct and bending stress. Okay, so what is direct stress? Direct stress is nothing but when it is subjected to axial tensile or compressive load. Okay, it is either only axial, so it is either compressive or tensile load. Okay, so when these loads are acting on a body, it will have direct stress. So இந்த மாதிரி ஸ்ட்ரெயிட்டாக வந்து உள்ளே வர மாதிரி இல்லை வெளியில் பிரிகிற மாதிரி லோடு ஆக்ட் ஆகுறப்ப அங்கே வந்து நம்மளுக்கு டைரக்ட் ஸ்ட்ரெஸ் ப்ரொடியூஸ் ஆகும். ஓகே, அண்ட் த அனதர் திங் பெண்டிங் ஸ்ட்ரெஸ். ஸோ வாட் இஸ் பெண்டிங் ஸ்ட்ரெஸ்? த ஸ்ட்ரெஸ் விச் இஸ் மெயின்லி ப்ரொடியூஸ்டு ஒன்லி டியூ டு த பெண்டிங் மூமெண்ட். அது பெண்ட் ஆகிறதுனால அங்கே ஸ்ட்ரெஸ் ப்ரொடியூஸ் ஆகிறது தான் பெண்டிங் ஸ்ட்ரெஸ். ஓகே, ஸோ பாடி சப்ஜெக்டட் டு ஆக்சியல் லோட் அண்ட் பெண்டிங் ஸ்ட்ரெஸ். ஸோ ரெண்டுமே நம்மளுக்கு வரணும், பிகாஸ் த டைட்டில் இஸ் கம்பைன்டு direct and bending stress. கரெக்டுங்களா? ஸோ the body subjected to axial load as well as the bending moment will give direct and bending stress. ஸோ அங்கே லோடும் இருக்குது பெண்டிங் மூமெண்ட்டும் இருக்குன்னா ரெண்டுமே நம்மளுக்கு கிடைக்கும், ரெண்டு ஸ்ட்ரெஸ்ஸுமே கிடைக்கும். ஓகேங்களா. So let's see how the resultant stress will be. ஓகேங்களா. So இந்த ரெண்டு ஸ்ட்ரெஸ்ஸுமே வந்து always acts normal to the cross section. It will act normal to the cross section. Okay. So add up together will give the resultant stress. So these two stresses will add up together to give the resultant stress. Okay. So it is a column which has the couple force. Couple na மேலேயும் இருக்கணும் கீழேயும் இருக்கணும். Okay, right? This is couple force. But here the one force is acting e distance. Yes, the one single force is acting at e distance, just beyond, just adjacent to the axis, right? Only one axis. So this is according to only one axis. Yes. Okay. So eccentric load will create bending stress and direct stress. Okay. So these load which has the eccentric distance, right? So this is eccentric load will create bending and direct stress. So ரெண்டுமே வந்து இந்த load வந்து create பண்ணும் because it is not actually acting in the axis, along the axis, right? It is somewhat e distance from the axis. Okay, so here the bending stress will be produced by bending moment, which is nothing but P into E. Bending moment na load into distance, right? So load into distance is PE. So this is what the bending moment. Okay, so first we're going to see for the first condition, like a column of rectangular section like this. A column of rectangular section subjected to eccentric load. You can see here eccentric load will cause direct and bending stress. Okay, so what will be the direct stress here? Direct stress is nothing but P by A, direct stress. But bending stress will be 6 times of PE by AB. Okay, so this is a formula, just remember it. So maximum stress will be, just add up together will give the maximum stress, and subtract it, it will give the minimum stress. Okay, so this is a formula for the direct stress and the bending stress, which is along only one axis. The eccentricity is along the one axis, right? The distance is along one axis. If it is for two axis, when a column of rectangular section is subjected to load which is eccentric to both axes. So இது வந்து ரெண்டு axisல distanceல வருது. ஓகேங்களா. So you can see here it is at the center actually, and this one is EX distance from here and EY distance from here. Like this is EX distance in the X axis and EY distance in the Y axis. Okay, so what is P here? Eccentric load on the column. EX means eccentricity of load at XX axis. Here it is at YY axis. The distance is at XX axis and this distance is at YY axis. இது வந்து XX axisல இருக்கிற distance, இது YY axisல இருக்கிற distance. ஓகேங்களா. ஸோ எப்படி சொல்லனா, இந்த distance வந்து இந்த axisல தான் நம்ம கம்பேர் பண்ண முடியும், இங்கே Yக்கு அது கிடையாது. ஸோ this distance will compare with the YY axis. So EY. ஓகேங்களா. P is just a load, eccentric load which has both, which is eccentric to the both axes, this P. Okay, and then sigma naught, which is nothing but direct stress. Okay, sigma B means bending stress, right? But here there are two axes, right? So sigma BX, sigma BY. So there are two axes due to EX, due to EY. Okay, so sigma BX means due to EX, sigma BY means due to BY. Okay, and then moment MX is along XX axis, MY means along YY axis. Okay, so MX will be equal to P into EX. So P distance into EX. My means P into EY, load into distance, load into distance. It is clear. So we have got mx, my here. Okay, so the first thing, stress, direct stress will be P by A, right? Then what about bending stress? Bending stress at By will be equal to My into x distance divided by Iyy. Here I is nothing but the moment of inertia about YY axis. So it will be here. Normally BDQ by 12. This is for the XX axis. But just reverse it. DBQ by 12. It will be for YY axis. Okay. So just substitute this here. Okay. So what is My here? My which is nothing but load into distance. Just substitute it. And you will get the three formulas. 1, 2, 3. Right. So the same accordingly same for the x axis, sigma bx. So எங்கெங்கெல்லாம் yx வருதோ அதை மட்டும் நீங்கள் ரிவர்ஸ் பண்ணிங்கன்னா you will get the sigma bx. ஓகே, இங்கே ஒரே ஒரு x மட்டும்தான், இந்த distance மட்டும்தான் x. This is the only thing which is x here. All are y. Same appears here. All are x. This is the only thing y here. Okay, so resultant stress will be at any point on the section will be sigma naught. This is direct stress and this is bending stress accordingly for y and x. Okay, just substitute it. But here it will be plus or minus. It will depends on the points. Okay, let me show you that. So the point C, point A, point B, point D. There are 4 points, right? So let's first see the point C. XY axis plus. So the both the bending stresses are positive here. So it will be maximum. And at A it will be negative. So it is minimum. Okay, just put positive here and the negativity minus. But in case of B, X is positive and Y is negative. Just substitute it like this, plus and minus. But in case of D, it will be minus and positive. So it will be minus here and it will be positive here. So these are the resultant stress accordingly for the 4 points. Okay. Okay, so thank you so much for watching this video, and in the next video there will be an important topic like theory of failures. Okay, it is that easy and it is important. Okay, so let's see those things, and in the next video I think I will complete this mechanics. Okay, solid mechanics. So do watch all the videos and do study it. This is the right time to study for your exams. Thank you so much.